Human Geography by Knox Marston, 7th edition, Chapter 4, People and Nature. In the late October 2013, the El Sipakatog First Nation, I'm so sorry if I mispronounced that, in New Brunswick, Canada, formed a blockade to stop an energy company from conducting shale oil and gas exploration on their land without their consent. The blockade was formed by approximately 300 tribal people as well as local community members. In reaction to the announcement by the SWN Resources Canada, a subsidiary of Houston based Southwestern Energy Company, that they would soon commence shale gas exploration in First Nations territory. The response to the blockade was swift and aggressive, with over 100 Royal Canadian Mounted Police launching a paramilitary assault on the group, brandishing rifles and accompanied by attack dogs. 40 participants were arrested and the blockade was broken up as SWN reconsidered how to proceed. Since the initial event, the Elsa Pogtog have been joined by another First Nations group, the Mi'kmaq, to carry on their objections to proposals by SWN to conduct hydraulic fracking on the shale sands that lie below their native lands. The tribes are arguing that SWN is violating treaty rights and fear for the effects fracking will have on their land and water, as well as the people and animals that depend on those resources. Groups across Canada, the United States, and the world have emerged to protest fracking, fearing the irreparable environmental damage will result from this extreme mining process. As of 2014, over 420 communities in the United States alone have passed measures to prohibit fracking on lands near or in their jurisdictions. Induced hydraulic fracturing or fracking is a mining process designed to extract previously inaccessible energy resources from subsurface geological formulations. In fracking, highly pressurized fluid, usually a combination of water, sand, and chemicals, is injected into a wellbore to create small fractures in a deep rock formations. The production of the fractures allows oil and gas to escape the location where they are trapped in underground shale formations and rise up the wellbore to the surface and thus become more readily available for capture. Fracking in Canada and the United States is presented as an alternative to North American dependence on fossil fuels, particularly oil found in the Middle East and other areas of the globe. Thus, fracking represents not just a technology meant to support continued economic growth, but also a geopolitical strategy to reduce dependence on foreign oil and to augment domestic supply and demand tensions. Unfortunately, fracking holds the potential to produce extensive, dramatic environmental damage that can result in toxic landscapes for both humans and animals, including poisoned water sources, denuded soil, and radioactive pollution affecting fish, wildlife, and human water systems. An example of these negative environmental effects is the 2011 Chesapeake Energy Corporation fracking accident that blew out a gas well in northeastern Pennsylvania. The explosion resulted in fracking fluid escaping from the well and flowing into the Susquehanna River and down into Maryland's Chesapeake Bay. The Environmental Protection Agency has identified more than 24 highly toxic and hazardous chemicals, including methanol, glutaraldehyde, I'm sorry if I mispronounced, formaldehyde, 2-butuxaethanol and hydraulic acid in the fluid that fracking pumps into the earth, in addition to the toxic and hazardous chemicals, along with water that are pumped into the wells to create the pressure necessary to release oil and gas from the shale reserves. Fracking waste fluids also contain contaminants picked up from deep within the earth, most notably heavy metals, volatile organic compounds, salty brine, and radioactive materials. Besides the environmental damage that can result from on site fracking, disposing of fracking's radioactive waste is another aspect of environmental concern. In March of 2014, a Pennsylvania based drilling company attempted to deposit two roll off boxes of sludge in a landfill in Chartiers, Pennsylvania, but tripped radioactivity alarms. Turned away from the Pennsylvania landfill, the company then hauled the radioactive sludge to a landfill in Bridgeport, West Virginia, which lacked a radiation detector. Since state law there does not require one, in fact, U.S. states have a diverse spectrum of laws regarding radioactive waste sludging, suggesting that some states are more likely to become depositories for radioactive fracking waste than others, even states that have no active fracking occurring within their jurisdiction. While fracking is widely used, response to decreasing access to more readily available oil and gas, and therefore offers a pathway to energy independence, at least temporarily, for countries like the United States, Canada, China, South Africa, and Australia, as well as parts of North Africa and Europe. It does not come without significant cost, even as popular opposition to fracking is growing globally. More and more wells are being opened. Yet, because fracking also provides jobs, resistance to its complicated by the opportunity for many who might not otherwise have access to employment. In the chapter that follows, we examine the nature society relationship by looking first at different approaches to it. We then examine how changing conceptions of nature have translated into very different uses of and adaptations to it. We conclude the chapter with an examination of sustainable development as a way of addressing global environmental problems and a discussion of the new institutional frameworks and activist organizations that are emerging to promote sustainability. Nature as a concept. As discussed briefly in Chapter 2, a simple model of the nature-society relation is that nature, though its grand force and subtle expressions, limits or shapes society. This model is known as environmental determinism. A second model posits that society also shapes and controls nature, largely through technology and social institutions. This second model, explored in this chapter, emphasizes the complexity of nature-society interactions. In this section, we explore the relationship between people, nature, and technology to understand how humans have shaped the earth, the natural world, and what those human impacts mean for Earth's future. The Earth Summit. Interest in the relationship between nature and society has experienced the resurgence as the scope of environmental problems over the last 50 years has widened to include not only those that are locally or regionally contained, but also those that have implications for the whole planet. The single most dramatic manifestation of this interest occurred in the summer of 1992, when more than 100 world leaders and 30,000 other participants attended the Second Earth Summit in Rio de Janeiro. The first Earth Summit was held in Stockholm in 1972. The central focus of the 1992 agenda was to ensure a sustainable future for the Earth by establishing treaties on global environmental issues, such as climate change and biodiversity, by raising public awareness of the need to integrate environment and development. The signatories to the 1992 Earth Summit Conventions created the Commission on Sustainable Development to monitor and report on implementation. 10 years later, Earth Summit 2002, also known as Rio Plus 10, was held in Johannesburg, South Africa. Its central aim was to assemble leaders from government, businesses, and NGOs to agree on a range of measures toward achieving sustainable development at the national, regional, and international levels. At this summit, the need to enhance the integration of sustainable developments in the activities of all relevant United Nations agencies, programs, and funds was highlighted. The Rio Plus 20, a celebration of the initial conference held in Rio in 1992, occurred in June of 2012. Also known as Earth Summit 2012, its goals are to secure renewed political commitment to sustainable development, to assess progress toward internationally agreed goals on sustainability or sustainable development, and to address new and emerging challenges. Rio Plus 20 focused on two specific themes: a green economy in the context of poverty eradication and sustainable development, and an institutional framework for sustainable development. Using Agenda 21 as its focal point, the outcome document from Earth Summit 1992, Rio Plus 20 sought affirmation for the political commitments made at past Earth Summits and set the global environmental agenda for the next 20 years. Agenda 21 was considered a revolutionary document in 1992, in that it not only popularized the term sustainable development, but also created an agenda that guided the next 20 years of government activities and policies toward improving the environment by increasing economic development in the world's periphery. Sustainable development seeks a balance among economic growth, environmental impacts, and social equity. The main outcome of Rio Plus 20 was a non-binding document, quote, "The Future We Want," in which the heads of states of the 192 governments attending the conference renewed their political commitment to sustainable development. They also declared their commitment to the promotion of sustainable future by reaffirming previous action plans like Agenda 21. Some very important changes have occurred since the first summit in Stockholm 40 years ago. One change has been the emergence of international institutions to facilitate and monitor environmental improvements. Another has been real progress on the global phase-out of leaded gasoline. A third has been increasing scientific and popular interest in global environmental issues. Perhaps most significant has been the proliferation of concern for sustainability, especially as it has broadened out from being a conference theme to a set practices being taken up by governments, corporations, public and private organizations, and individuals. Among these new practices, and objectives are environmental restoration, green urban development, the use of alternative energy technologies such as wind, geothermal, solar, and nuclear energy, sustainable tourism, greening, quote, of the commodity supply chain, sustainable agriculture, promotion of biomass, the total mass of organisms in a given area of volume, and biofuels, green real estate development, green government practices, the emergence and growth of carbon markets, the transition of towns towards sustainability, the construction of sustainable buildings, and green marketing. Alternative solutions to environmental problems. In the past, technology was viewed as the obvious solution to the most environmental problems. But today's technological progress seems to often to aggravate rather than to solve such problems. As a result, researchers and activists have begun to ask different questions and to abandon assumption that technology is the only solution. For instance, philosopher and environmental activist Vandana Shiva has led a broad-based and increasingly global movement advocating changes in agriculture and food production practices. In 1982, she established the Research Foundation for Science, Technology, and Ecology, and in 1991, she founded Navdanya, a social movement with the goal of protecting the diversity and integrity of living resources, especially promoting the use and preservation of native seeds, organic farming, and fair trade. In India, Navdanya has successfully conserved more than 5,000 crop varieties, created awareness of the hazards of genetic engineering, and defended people whose food rights are under threat from globalization and biopiracy, a, a controversial practice with many conflicting definitions. Biopiracy is the commercial exploitation of biological materials that is living matter, including anything from genetic cell lines to plant or animal substances, and patenting that material. Excuse me. It's kind of, with compensation, the peoples whose knowledge revealed the value of them or on whose territory it was discovered. Navdanya and other movements like it have influenced environmental experts, including a number of geographers, to conceptualize nature not as something apart from humans, but as inseparable from us. These experts believe that nature and questions about the environment need to be considered in conjunction with society, which shapes our attitudes toward nature and how we identify sources of and solutions to environmental problems. Such an approach, thinking of nature and society as interactive components of a complex system, enables us to ask new questions and consider alternatives to our current practices. With respect to nature, one such practice is described in Box 4.1, Geography Matters. I'm going to go ahead and let you guys take a look at this chart. Let's see if I can get close enough without glare. Sorry about that. And then here's Vandana Shiva. Nature and society defined. Sorry about that. The central concepts of this chapter, nature and society, have very specific meanings. Although we discuss in the changing conceptions and understandings of nature in some detail, we hold to one basic conception here. The nature is a social creation as much as it is a physical universe. That includes human beings. Therefore, understandings of nature are the product at different times and different needs. Nature is not only an object, it is a reflection of society in that the philosophies, belief systems, and ideologies people produce shape the way we think about and use nature. The relationship between nature and society is two-way. Society shapes people's understandings and uses of nature at the same time that nature shapes society and its many manifestations. The amount of shaping by society is dependent to a large extent on the state of technology and the constraints on its use at any given time. Society is the sum of the inventions, institutions, and relationships created and reproduced by human beings across particular places and times. Society's relationship with nature varies from place to place and among different social groups. The relationship between society and nature is usually mediated through technology, knowledge, implements, arts, skills, and the socio-cultural context are all components of technology. If we accept that all these components are relevant to technology, then we can provide a definition that has three distinguishable, though equally important aspects. Technology is defined as physical objects or artifacts, example, the plow, activities or processing, example, steelmaking, knowledge or know how, the example is biological engineering. This definition recognizes tools, application, and understandings equally as critical components of technology. The manifestations and impacts of technology can be measured in terms of concepts such as level of industrialization and per capita energy consumption. The definitions provided in this section reflect current thinking on the relationship between society and nature. For centuries, humankind, in response to the constraints of the physical environment, has been as much influenced by prevailing ideas about nature as by its realities. In fact, prevailing ideas about nature have changed over time as evidence from literature, art, religion, legal systems, and technological innovations makes abundantly clear. The complex relationship of environmental impacts, population, and affluence. Concern about global environmental changes has given rise to a recent attempt to conceptualize the relationship between society and the environment based on the premise that individual societal changes can be both subtly and dramatically related to environmental changes. A formula now widely used for distinguishing the sources of social impacts on the environment is 1 equals PAT. It relates human population pressures on environmental resources to a society's level of affluence and access to technology. More specifically, the formula states that I equals PAT, where I impact on Earth's resources, is equal to P population times A affluence is as measured per capita income times T a technology factor. According to this formula, the differential impact on the environment of two households' food consumption in two different places would equal the number of people per household times per capita income of the household times the type of technology and energy used in producing foodstuffs for that household. Each of the variables in the formula, population affluence, and technology, is complex. For example, with regard to population numbers, it is generally believed that fewer people on the planet will result in fewer direct pressures on resources. Some argue, however, that increased world population is quite desirable, since more people means more labor, coupled with more potential for the emergence of innovation to solve present and future resource problems. Clearly, there is no simple answer to the question of how many people are too many. Affluence cannot simply be assessed in terms of less is better. Certainly, increasing affluence, a measure of per capita consumption multiplied by the number of consumers and the environmental impacts of their technologies, is a drain on Earth's resources and a burden on Earth's ability to absorb waste. Yet, how much of affluence is too much is difficult to determine. Furthermore, evidence shows that the core countries with high levels of affluence are more effective than the poor countries of the periphery at protecting their environments. Unfortunately, countries often do so by exporting. I'll come back to this one. Exporting their noxious industrial processes and waste products. to peripheral countries by exporting polluting industries and the jobs that go with them. However, core countries may also be contributing to increased affluence in the receiving countries. Given what we know about core countries, such a rise fosters a set of social values that ultimately leads to better protection of the environment in a new place. It is difficult to identify just when environmental consciousness goes from being a luxury to a necessity. The role of affluence in terms of environmental impacts is, in short, like population, difficult to assess. Not surprisingly, the technology variable is no less complicated. Technologies affect the environment in three ways, though: the harvesting of resources, the emission of waste in the manufacture of goods and services, and the emission of waste in the consumption of goods and services. A technological innovation can create access to an existing resource that was otherwise not available for use. In addition, technology can sometimes be a solution and sometimes a problem. Both principles can be seen in the case of fracking that opened this chapter. Producing this energy creates hazards at the same time that it threatens other important resources, such as safe water supply. It is therefore clear that increases in human numbers, in levels of wealth, and in technological capacity are key components of social and economic progress that have had an extreme complex impact on the environment. In the last 100 years, the complexity has come to be seen as a triple-barreled threat to the quality of the natural world and the availability and quality of environmental resources. Before we look more carefully at the specific impacts of population, affluence, and technology on nature, we need to first look at how differing social attitudes toward nature shape the human behaviors that are a basis for I equals PAT. Let me go ahead and go back because there are a couple things that need to be noted. Here is the map for the area. Here is Geography Matters, the political ecology, carbon offsets. Nature-society interactions. The concept of adaptation to the natural environment is part of the geographical subfield of cultural ecology most closely associated with the work of Carl Sauer and his students. Cultural ecology is the study of how human society has adapted to environmental challenges like aridity and steep landscapes through technologies such as irrigation and terracing, and organizing people to construct and maintain these systems. These adaptations can be seen clearly in the race terraces of Southeast Asia or the canals and reservoirs of the southwestern United States. More recent adaptations include the use of biotechnology and agricultural chemicals to increase agricultural production and the development of new pharmaceuticals to cope with diseases. Indeed, it has been argued that climate adaptation measures reducing fossil fuel consumption, adopting more sustainable farming practices, and recycling are a form of cultural ecology. We discuss these and others such adaptations through this chapter. Before the 1980s, the principles of cultural ecology did not include the political dimensions of ecological questions. But since then, ecologists have moved away from a strict focus on particular cultural groups' relationship with the environment, placing that relationship within a wider context instead. The result is political ecology, the merging of political economy with cultural ecology. Political ecology stresses that human environment relations can be adequately understood only by relating patterns to resource use to political and economic forces, particularly the way that national states and capitalist economic practices can lead to as well as exacerbate environmental degradation. Political ecology is understood to have three fundamental assumptions. The cost and benefit associated with environmental change are distributed unequally because changes to the environment are not themselves homogeneous. Here's the chart. Number two, this unequal distribution of environmental change inevitably reinforces or reduces existing social and economic inequalities. The unequal distribution of environmental change results in the unequal distribution of costs and benefits affecting pre existing inequalities and altering power relationships. Environmental attitudes. Environmental attitudes and philosophies in the United States. As we mentioned at the beginning of this chapter, nature is a construct that is shaped by social ideas, beliefs, and values. As a result, different societies and different cultures have different views of nature. In the contemporary world, views of nature are dominated by the Western, also known as Judeo Christian, tradition that understands humans to be superior to nature. In this view, nature is something to be tamed or dominated, but other views of nature have emerged that depart dramatically from the dominant view. These include the environmental philosophies that became popular in the 19th and early 20th centuries, and the more radical political views of nature that gained prominence in the late 20th century. Among the latter are approaches based on ecotheology, including Christianity, Hinduism, Islam, and Judaism, which reject the long standing Western tradition. Figure 4.5 provides a snapshot of changing attitudes in the United States towards the environment over nearly 3 decades. Here's a close-up of that, should you want to look into that. Classical and environmental philosophies. Henry David Thoreau, 1817 to 1862, an American naturalist and activist, perhaps best illustrates a view that began to emerge in the mid-19th century. In the United States, the incorporation of North American Indian conceptions of nature into approaches to ecology. Thoreau lived and studied the natural world around the town of his birth, Concord, Massachusetts. He is most famous for his book Walden, which chronicles the 2 years he spent living and observing nature in solitude in a house he built at Walden Pond. Thoreau, go ahead and do that real close. Thoreau represented a significant alternative to the humans over nature approach that characterized his times. Many people regard him as the originator of a U.S. environmental philosophy. Thoreau was impressed with the power of nature. He emphasized the interrelatedness of the natural world, where birds depended upon worms, fish depended upon flies, and so on along the food chain. Most notably, however, Thoreau regarded the natural world as an antidote to the negative effects of technology on the landscape. And the American character, Concord was just 32 kilometers, 20 miles west of Boston and an equal distance south of the booming mill towns of Lowell and Lawrence. Although he spent his life in a more or less rural setting, the Industrial Revolution was in full force all around. Thoreau and he was keenly aware of its impacts. His research on the animals and plants that surrounded Concord was an attempt to reconstruct the landscape as it had existed before colonization and massive European immigration. Thoreau's ideas embraced European notions of Romanticism, a philosophy that emphasized the interdependence of humans and nature, in direct revolt against those who espoused a Judeo Christian understanding of nature. The Romantics believed that all creatures, human and otherwise, were infused with a divine presence that commanded respect, and that humans were not exceptionally in this scheme. Rather, human divinity issued from humble participation in the natural community, a branch of American Romanticism known as Transcendentalism. Also, also influenced understandings of nature during the early 1800s. Transcendentalism, was espoused most eloquently by Unitarian minister turned poet and philosopher Ralph Waldo Emerson, a neighbor and contemporary of Thoreau. It encouraged people to attempt to rise above nature and the limitations of the body to the point where the spirit dominates the flesh and a mystical and spiritual life replaces a primitive and savage one. Thoreau and Emerson are two of the most important influences on contemporary American ideas about human nature relationship. Another major influence on U.S. environmentalism was George Perkins Marsh, a narrative Vermonter who, in 1864, wrote a treatise entitled Man and Nature, or Physical Geography as Modified by Human Action, heavily revised and republished in 1874 as The Earth as Modified by Human Action. The first work suggests that human beings are significant agents of environmental change. It is considered one of the most important advances in geography, ecology, and resource management. In the 19th century, Marsh's ideas served as the foundation of the U.S. environmental movement in the 20th century. Early in the 20th century, writers like Gifford Pinchot and politicians like Theodore Roosevelt drew on the ideas of Thoreau, Emerson, and Marsh to advocate the wise use of natural resources and the conservation of natural environments. Their view that nature should be conserved as has survived to the present. Conservation holds that natural resources should be used thoughtfully and that humans should serve as stewards, not exploiters, of the natural world. Conservation implies responsibility to future generations as well as to the natural world itself. In the utilization of resources, the writings of all these individuals eventually helped to inspire a wide range of environmental organizations, including Environmental Defense Fund, World Watch Institute, the Sierra Club, and the Nature Conservancy. Those who espouse a more radical approach to nature see the conservation approach as too passive to be truly effective in protecting the environment. Such individuals believe that conservation leaves intact the political and economic system that drives the exploitation of nature. They believe that nature is sacred and should be preserved, not used at all. This extreme position preservation advocates that certain habitats, species, and resources should remain off limits to human use, regardless of whether the use maintains or depletes the resource in question. Here is excuse me. Contemporary environmental philosophies. Environmental ethics is a philosophical perspective that prescribes moral principles as guidance for our treatment of nature. From this perspective, society has a moral obligation to treat nature according to the rules of moral behavior that exist for human beings. An aspect of environmental ethics that has caused a great deal of controversy is the idea that animals, trees, rocks, and other elements of nature have rights in the same way that humans do. If the moral system of our society insists that humans have the right to a safe and happy life, then it is argued that the same rights should be extended to non human nature. Ecofeminism holds that patriarchy, a system of social ideas that values men more highly than women, is at the center of our present environmental melees. Because patriarchy has equated women with nature, it has promoted the subordination and exploitation of both. The many varieties of ecofeminism range from nature-based spirituality, oriented toward a goddess to a more political approaches that emphasize resistance and opposition to the dominant models that devalue what is not male. Some ecofeminists are also environmental ethics. Not only a movement of the core, ecofeminism has also been widely embraced in the periphery, where women are primarily responsible for the health and welfare of their families in environments that are being rapidly degraded. Their families in environments that are being I cannot believe I said that twice. Their families, environments that are being rapidly degraded. The unifying objective in all of ecofeminism is to dismantle the patriarchal biases in Western culture and replace them with a perspective that values social, cultural, and biological diversity. Deep ecology, which shares many points of view with the ecofeminism, is an approach to nature revolving around two key components: self realization and biospherical egalitarianism. Self realization embraces the view that humans must learn to recognize they are part of the non human world as a form of egalitarianism. Deep ecology insists that Earth, or the biosphere, is the central focus of all life and that all components of nature, human and non human, deserve the same respect and treatment. Deep ecologists, like environmental ethicists, believe that is no absolute divide between humanity and everything else, and that a complex and diverse set of relations constitutes the universe. The belief that all things are internally related should enable society to treat the non human world with respect and not simply as a source of raw materials for human use. The environmental justice EJ movement considers the pollution of neighborhoods by, for example, factories and hazardous waste dumps to be the result of a structured and institutionalized inequality that is pervasive in both the capitalist core and the periphery. EJ activists see their issues as distinct from those of middle class mainstream groups like the Sierra Club or even Greenpeace for environmental justice activists. Their struggles are uniquely rooted in their economic status. Thus, theirs are not quality of life issues, such as whether any forest will be left for recreation, but sheer economic and physical survival. As a result, the questions raised by EJ activists involve the distribution of economic and political resources. Such questions are not easily resolved in courts of law, but speak more complicated issues such as the nature of racism and sexism and of capitalism as a class-based economic system. Like ecofeminism, the environmental justice movement is not restricted to the poor. Indeed, poor people throughout the world are concerned that the negative impacts of economic development can constantly affect them more than the rich. Eco-theology calls for reevaluation of the Western relationship to nature. The term came into prominence in the late 20th century, mainly in Christian circles, though it has since spread across religious boundaries. In association with the scientific field of ecology, within religious circles, there is a fear that science may not be capable of inspiring the changes in behavior necessary to thwart continuing environmental destruction. Ecotheologists also argue that capitalist political and economic, excuse me, institutions actively contribute to the environment degradation. In their view, it has become necessary, therefore, to address the current environmental crisis through belief systems that will overcome the inadequacies of humanly created institutions. Ecotheology recognizes the values of other creatures and God's intent for the cosmos as the basis for developing ethical models. Sorry. Ethical models that take into account politics, economics, and practical issues in the quest for the intelligent environmental policies. All of these contemporary philosophies of nature attest to a growing concern over the environmental effects of globalization, acid rain, deforestation, the disappearance of species, nuclear accident, and toxic waste have all been important stimuli for newly emerging philosophies about the relationships between society and nature within a globalizing world. While none of these philosophies is a while none of these God, I'm so sorry, guys. And toxic waste have been important stimuli for newly emerging philosophies about the relationships between society and nature within a globalizing world. While none of these philosophies is a panacea, each has an important critique to offer. More than anything, however, each serves to remind us that environmental crises are not simple, and simple solutions will not suffice. I'm sorry, guys. It's one of those days. Sorry about that. Global change in the Anthropocene. In this section, we build on our understanding of attitudes and practices toward nature by considering Nobel Prize winning atmospheric chemist Paul Crutzen's characterization of our current era. He coined the term Anthropocene to signal the current geological era in Earth's history in which the extent of human activities from agriculture to industrialization to urbanization have had far-reaching effects on Earth's ecosystem. An ecosystem is a community of different species interacting with each other and with the larger physical environment that surrounds it. We begin our discussion with European colonial expansion as it introduced new forms of agriculture, industry, and accelerated the development of cities throughout the globe. We end the section with a discussion of global climate change as a manifestation of the cumulative effects of human resource exploitation of Earth's atmosphere today. European colonial expansion. The history of European expansion provides a powerful example of how a society possessing new environmental attitudes was able to radically transform nature. These new attitudes drew upon a newly emerging science and its contribution to technological innovation, as well as the capitalist political and economic system that was being consolidated across Europe. This history also provides a helpful foundation for understanding the attitudes and practices that have helped produce some of our biggest environmental challenges today. Initially, European expansion was internal, largely contained within continental boundaries. The most obvious reason for expansion was population increase from 36 million in 1000 to over 44 million in 1100, nearly 60 million in 1200, and 80 million by 1300. As population increased, more land was brought under cultivation. In addition, more forests were cleared for agriculture, more animals were killed for food, and more minerals and other resources were exploited. For a variety of needs, forests originally covered upward of 90% of Western and Central Europe. At the end of the period of an internal expansion, however, around 1300, the forested area amounted to only 20%. Here is the graph for this section. In the 15th century, Europe underwent its second phase of expansion. This phase was external and not only changed the global political map, but also launched a period of environmental change that continues to this day. European external expansion, colonialism was the response to several impulses ranging from self-interest to altruism. Europeans were fast running out of land, and as we saw in Chapter 2, explorers were being dispatched by monarchs to conquer new territories, enlarge their empires, and collect tax revenues from new subjects. Many of these adventurous individuals were also searching for fame and fortune or avoiding religious persecution. Behind European external expansion, also known the Christian impulse to bring new souls into the kingdom of God. Other forces behind European colonialism included the need to expand the emerging systems of trade, which ultimately meant increased wealth and power for a new class of people. The merchants, as well as for the aristocracy, over the centuries, Europe came to control increasing areas of the globe. Two examples we discuss in the next sections of the chapter illustrate how the introduction of European peoples, ideologies, technologies, plant species, pathogens, and animals changed the environments into which they were introduced, and also societies they encountered. Disease and depopulation in the Spanish colonies. Historians, sorry about that, guys, generally agree that European colonization of the New World was eventually responsible for the greatest loss of human life in history. Historians also agree that the primary reason for that loss was disease. New World population, isolated for millennia from the Old World, possessed immune systems that had never encountered some of the most common diseases. Virgin soil epidemics, in which the population at risk has no immunity or previous exposure to the disease within the lifetime of the oldest member of the group, were common in the so-called Columbian Exchange. Though in this case, mostly one way, the Columbian Exchange was the interaction between the Old World Europe and the New World, the Americas, initiated by the voyages of Columbus. Diseases such as smallpox, measles, chickenpox, whooping cough, typhus, typhoid fever, bubonic plague, cholera, scarlet fever, malaria, yellow fever, diphtheria, influenza, and others were unknown in the pre-Columbian New World. Scholars refer to the phenomena of near genocide of native populations as a demographic collapse of the ecological effect of the population decline caused by the high rates of mortality was the transformation of many regions from productive agricultural land to abandoned land. Many of the Andean terraces, for example, were abandoned, and dramatic soil erosion ensued. And large expanses of cleared land eventually returned to forests in areas such as the Yucatan. Oh, I'm going to go ahead and give you guys the map. Oof, sorry about that. Let's see if I can get this without a glare. Okay. The video will not allow me to pause, so I am sorry about that. I'm going to try and get this without a glare. I can zone in here so that you can see the first voyages. And here's... got a lot of light. There we go. Sorry about that. Okay. Let's continue. Old World plants and animals in the New World. A second case study of the environmental effects of European colonization involves the introduction of Old World plants and animals into the New World, and vice versa. The introduction of exotic plants and animals into new ecosystems is called ecological imperialism. A term now widely used by geographers, ecologists, and other scholars of the environment. The interaction between Old and New Worlds resulted in both the intentional and unintentional introduction of new crops and animals on both sides of the Atlantic. Europeans brought from their homelands many plants and animals that were exotics, that is, unknown to the American ecosystem. For example, the Spanish introduced wheat and sugarcane, as well as horses, cattle, and pigs. These introductions altered the environment, particularly as the emphasis on select species led to a reduction in the variety of plants and animals that constituted local ecosystems. Inadvertently, introductions of hardy exotic species included rats, weeds, such as the dandelion and thistle, and birds, such as starlings, which crowded out the less hardy indigenous species. As with the human population, the indigenous populations of plants, birds, and animals had few defenses against European plant and animal diseases, and were sometimes seriously reduced or made extinct through contact. Contact between Old and the New World was, however, a two-way process. New World crops and animals, as well as pathogens, were likewise introduced into the Old World, sometimes with devastating effects. Corn, potatoes, tobacco, cocoa, tomatoes, and cotton were all brought back to Europe. So was syphilis, which spread rapidly throughout the European population. Importantly, contacts between Europe and the rest of the world, though frequently violent and exploitive, were not uniformly disastrous. There are certainly examples of contacts that were mutually beneficial. The largely favorable ones were mostly knowledge-based or nutritional. Columbus's voyages added dramatically to global knowledge, expanding understanding of geography, botany, zoology, and other rapidly growing sciences. The encounter also had significant nutritional impacts for both sides by bringing new plants to each. European colonization, although responsible for the extermination of hundreds of plants and animal species, was responsible for increasing the types of and amounts of foods available worldwide. It is estimated that the Columbian Exchange may have tripled the number of cultivatable food plants in the New World. It certainly enabled new types of food to grow in abundance where they had never grown before, and it introduced animals as an important source of dietary protein. The advantage of having a large variety of food plants are myriad. For example, if one crop fails, another more than likely will succeed because not all plants are subject to failure from the same set of environmental conditions. Before the Columbian Exchange, the only important sources of animal energy in the New World were the llama and the dog. The introduction of the horse, the ox, and the donkey created a virtual power revolution in the New World. These animals also provided fibers and, after death or slaughter, hides and bones to make various tools, utensils, and coverings. Most significant in its environmental impact, however, was the ox. Land that had escaped cultivation because the indigenous digging sticks and tools were unable to penetrate the heavy soil and matted root surface became workable with an ox-drawn plow. The result was that the indigenous form of intensive agricultural production, small area, many laborers, was replaced by extensive production, large area, fewer laborers. This transformation was not entirely without negative impacts such as soil destabilization and erosion. Indigenous people and their pre Columbian environments. When discussing the impact of exchange, it is important to acknowledge Native world peoples and their relationship with the environment. The popular image of indigenous people living in harmony with nature, having only a minimal effect on their environment, is flawed in reality. Different groups had different impacts, and it's erroneous to conflate with the thousands of groups into one romanticized caricature in New England. For example, prior to European, some groups hunted for wild game and gathered wild foods. More sedentary types living in permanent and semi-permanent villages cleared and planted small areas of land. Hunter-gatherers were mobile, moving with the seasons to obtain fish, migrating birds, deer, wild berries, and plants. Agriculturalists planted corn, squash, beans, and tobacco and used a wide range of other natural resources. The economy was a fairly simple one based on personal use or on barter. Example, the trading corn for fish. The idea of a surplus was foreign. People cultivated or exploited only as much land and resources as they needed to survive. Land and resources were shared without concepts such as private property or land ownership. Fire was used to clear land for planting as well as for hunting. Although vegetation change did occur, it was minimal and not irreversible. Native peoples of South and Central America altered their environment as well, though perhaps in more dramatic ways. The Aztecs of Mexico and the Incas of Peru had developed complex urban civilizations, many of them more sophisticated and highly populated than any European city, dependent on dense populations and employing intensive agricultural techniques. On the urban outskirts, these groups were responsible for environmental modifications through cultivation techniques that included the irrigation of dry regions and the terracing of steep slopes. Irrigation over several centuries results in the salinization of soils. In the lowland tropics, intensive agricultural practices resulted in widespread deforestation. As people cut and set fires to patches of forest, planted crops, and then moved on when soil fertility declined, unlike North America, a surplus was key to the operations of both societies, as tribute by ordinary people to the political and religious elite was required in the form of food, animals, labor, or precious metals. The construction of the sizable Inca and Aztec empires required the production of large amounts of building materials in the form of wood and mortar. Concentrated populations and demands of urbanization meant that widespread environmental degradation existed prior to European contact. Global climate change. In the 400 years since Columbian exchange occurred, Earth has been dramatically transformed through human adaptation to the environment as well as exploitation of its resources. In some cases, the humans' use of nature has resulted in degradation or pollution. For example, the over cultivation of steep slopes has resulted in erosion of the soil needed for subsequent agricultural production, and the use of toxic agricultural chemicals has caused the contamination of rivers and lakes. The Industrial Revolution produced a dramatic growth in the emissions of waste material to land, water, and the atmosphere and resulted in serious air pollution and health problems in many areas. The emissions and the associated pollution persist to this day. Provides a snapshot of how the last 200 years of burning fossil fuels for heat, light, movement, and improvement of daily life has conveyed carbon dioxide emissions into the atmosphere. We talk at length about these effects in the next major section of the chapter. Here we wish to focus specifically on human-induced, also called anthropogenic change on Earth's atmosphere by examining the complexities of climate change. What is climate change? Climate change is defined by the Intergovernmental Panel on Climate Change, IPCC, as a change in the state of the climate that can be identified, e.g. using statistical tests, by changes in the means and or the variability of its properties and that persists for an extended period, typically decades or longer. It refers to any change in climate over time, whether due to the natural variability or as a result of human activity. Scientists are largely in agreement that global and regional climates have varied over geological time, largely due to slight changes in the tilt of Earth's axis in its orbit around the Sun or associated changes in the amount of solar radiation reaching Earth. They also recognize that the climate has changed over time because of large-scale events such as volcanic eruptions. This kind of climate change Earth is currently experiencing, however, is largely due to human activity that is altering the composition of the atmosphere. Of greatest concern is global warming, an increase in world temperatures and change in climate associated with increasing levels of carbon dioxide, CO2, methane, and other trace gases. These so-called greenhouse gases, GHGs, result from human activities such as burning of fossil fuels, cement production, and deforestation. Greenhouse gases act to trap heat within the atmosphere, resulting in its warming as well as that of Earth's surface. Here's a chart. I'll clue in on that so you can kind of see the numbers a little better. How do we know climate is changing? It's important to appreciate that climate change is not an assertion based on a speculative theory or a political agenda. The evidence for it's based on facts, many of which are identified next. Temperature increase is widespread over the globe and is greater at higher northern latitudes in the past 100 years. Average Arctic temperatures have increased at almost twice the global average rate. Global average sea level rose at an average rate of 1.8, 1.3 to 2.3 millimeters per year over 1961 to 2003, at an average rate of about 3.1, 2.4 to 3.8 millimeters per year from 1993 to 2003. Satellite data since 1978 show that annual average Arctic sea ice extent has shrunk by 2.1 to 3.3% per decade, with larger decreases in summer of 7.4, 5.0 to 9.8% per decade. Mountain glaciers and snow cover have declined on average in both hemispheres. Since 1990, Since 1990, precipitation has increased significantly in eastern parts of North and South America, Northern Europe, and Northern and Central Asia, whereas precipitation declined in the Sahel, the Mediterranean, Southern Africa, and parts of Southern Asia. Globally, the area affected by drought has likely increased since the 1970s. Average Northern Hemisphere temperatures during the second half of the 20th century were very likely higher than during any other 50-year period in the last 500 years, and likely the highest in at least the past 1,300 years. What are some projected impacts of these changes? The effects of climate change are not only expected to happen in the future, many of them are already occurring. Based on a range of models, it is likely that future tropical cyclones, typhoons, and hurricanes will become more intense with larger peak wind speeds and more heavy precipitation associated with ongoing increases of tropical sea surface temperatures. Crop productivity is projected to increase slightly at mid to high latitudes for local mean temperature increases up to 1 degree to 3 degrees Celsius, depending on the crop, and then decrease beyond that in some regions. At lower latitudes, especially in seasonally dry and tropical regions, crop productivity is projected to decrease for even small local temperature increases, 1 degree to 2 degrees, which would increase the risk of hunger. Coasts are projected to be exposed to increasing risk, including coastal erosion due to climate change and sea level rise. A rising sea level would be disastrous for some countries. About 70% of Bangladesh, for example, is at sea level, as is much of Egypt's most fertile land in the Nile Delta. Here's a graph. Excuse me. The health status of millions of people is projected to be affected through, for example, increase in malnutrition, increased deaths, diseases, and injury due to extreme weather events, increased burden of diarrheal diseases, increased frequency of cardiorespiratory diseases due to higher concentrations of ground level ozone in urban areas related to climate change, and the altered spatial distribution of some infectious diseases. Global climate change is causing sea levels to rise as polar ice caps melt, which will greatly affect coastal areas across the globe. This effect is already occurring in northern polar regions as well as among small islands in the southern hemisphere. Population growth patterns and the changing geography of economic development allow us to predict with some confidence that the air and water pollution generated by low-income countries will continue more than double in the next 10 to 15 years as they become more industrialized. Climate change is already exacerbating current stresses on water resources from population growth and economic and land use change, including urbanization. The resilience of many ecosystems is already compromised in some places and is likely to be exceeded in this century by an unprecedented combination of climate change associated disturbances. The example is flooding, drought, wildfires, insects, ocean acidification, and other global change drivers. The example: land use change, pollution, fragmentation of natural systems, overexploitation of resources. The causes and consequences of these global climate changes vary considerably by where in the world they are unfolding. For example, the industrial countries have higher carbon dioxide emissions. Increased carbon dioxide emissions are contributing to rising temperatures through the trapping of heat in the Earth's atmosphere. In order to survive in many of the world's peripheral regions, the rural poor are often impelled to degrade and destroy their immediate environment by cutting down forests for fuel wood, leading to the destruction of, of forests which help to cool Earth's surface. Thus, both the core and the periphery are contributing to the problem of global climate change in different but significant ways. Moreover, environmental problems are becoming inseparable from processes of demographic change, economic development, and human welfare, and are becoming increasingly enmeshed in matters of national security and regional conflict. What's to be done? There are many ways that individuals, organizations, and governments can begin to address the effects of climate change as described earlier. From using compact fluorescent light bulbs, buying local products, and using reusable water bottles instead of disposable ones, developing and expanding local food resources, and supporting clean energy sources such as solar and wind power. One increasing popular strategy for reducing GHGs is emissions trading. Already an established practice, emissions trading allows governments to regulate the amount of emissions produced in aggregate by setting the overall cap, but allowing corporations the flexibility of determining how and where the emissions reductions will be achieved. Corporations that want to limit their emissions are allocated allowances, with each allowance representing a ton of the relevant emissions, such as carbon dioxide. Corporations can emit in excess of their allocation of allowances by purchasing allowances from the market. Similarly, a company that emits less than its allocation of allowances can sell its surplus allowances. The climate change controversy. Despite overwhelming consensus from the international scientific community, a small number of critics, known as climate change deniers or skeptics, do not accept that Earth's climate is being changed by human activities. These individuals are generally not climate scientists, and they do not publish in peer-reviewed scientific journals or engage in debate at conferences on climate science. Yet many of them are influential individuals as members of Congress or as chief officers of large corporations, and such have access to news media that feel compelled to offer a balanced perspective on the problem. The objective of this group of climate skeptics is to delay or prevent action by government to address climate change, such as initiatives to push for alternative energy sources or tighter regulations for high polluting energy like coal. Their approach has been to insist that global warming is a theory, not a fact, and as such, little or no regulatory action is needed. A comprehensive study of 928 articles published on climate change in peer-reviewed scientific journals over a 10-year period found that not one of the articles disagreed with the scientific consensus that human-induced climate change is occurring. To gain a better understanding of the arguments advanced by climate change deniers, click on the following link to an article in Scientific American that addresses them. It provides fact-based evidence to rebut climate change skepticism. The IPCC's fifth assessment report, Mitigation of Climate Change 2014, provides helpful data about the state of the world's climate and efforts to mitigate the effects of global warming in a format that is easily accessible to a lay audience. The report understands mitigation as an effort to stabilize greenhouse gases in the atmosphere to prevent the dangerous effects of human induced change. It also recognizes that mitigation must be achieved in such a way that ecosystems will not be fatally threatened, food production will not be compromised, and economic development will not occur in a sustainable manner. Here's the things. Sorry. And then here, I'll try and get as close as I can because this shows where observed impacts. Okay. Sorry about that. Energy, land use, change, and environment. Certainly, most central and significant technological breakthrough of the Industrial Revolution was the discovery and utilization of fossil fuels, coal, oil, and natural gas. Although the very first factories in Europe and the United States relied on water powered to drive machinery, hydrocarbon fuels provided a more constant, dependable, and effective source of power. A steady increase in power production and demand since the beginning of the Industrial Revolution has been paralleled, not surprisingly, by an increase in resource extraction and conservation. I'm sorry. Not so. Oh, conversion. Resource extraction and conversion. See box 4.2. Spatial inequality, energy consumption, and production provides insight into global variation that exists in the energy use, energy needs, and environmental impacts. The burning of home heating oil, along with the use of petroleum products for fuel and in internal combustion engines, also launches harmful chemicals into Earth's atmosphere, causing air pollution and related health problems. The production and transport of oil have resulted in oil spills and substantial pollution of water and ecosystems. Media images of damage to seabirds and mammals after tankers have run aground and spilled oil have shown how immediate the environmental damage can be. Indeed, the oceans are acutely affected by the widespread use of oil for energy purposes. There is no better example of the damage of oil spills to the environment than the accident that occurred when British Petroleum Deepwater Horizon oil rig exploded and caught fire on April 20th, 2010 in the Gulf of Mexico, 400 kilometers, 250 miles offshore of Houston. The explosion killed 11 people and injured at least two dozen more when a blowout preventer intended to check the release of oil failed to activate. As the well continued to leak an estimated 40,000 barrels of oil a day before it was effectively capped. Oil slicks spread across the Gulf from Florida to Texas, contaminating the environment and seriously damaging the Gulf coastal fisheries and tourism economy, especially in Louisiana, Mississippi, Alabama, and northern Florida. When the well was finally capped 3 months after the explosion, it is estimated that a total of 4.9 million barrels or 205.8 million gallons of oil had been released into the environment. As the world's largest accidental oil spill to date, it will continue to contaminate or damage marine and terrestrial life, both human and non-human. Despite the huge cost of The Gulf oil spill cleanup, estimated at $40 billion to British Petroleum Company, registered a 17% profit in its 2011 first quarter earnings. Natural gas is one of the least noxious of the hydrocarbon based energy resources because its combustion is relatively clean. Now supplying nearly one quarter of global commercial energy, natural gas is predicted to be the fastest growing energy source in the country. In this country, reserves are still being discovered, with Russia holding the largest amount, about one third of the world's total. While regarded as preferred alternative to oil and coal, natural gas is not produced or consumed without environmental impacts. The risk of explosions at natural gas conversions facilities is significant. Groundwater contamination and leakages and losses of gas from distribution systems contribute to the deterioration of Earth's atmosphere, as well as the increasingly some of the unintended effects of fracking as a form of natural gas mining. Here's the oil spill. And then here is an aerial view of Louisiana. I'm going to show you. See if I can get this without. So you can read that. And then here's this map. And then here is top 5 energy companies in the world revenue. Here's the thing on spatial inequality. This is the blue part of the chapter, but I want to make sure that I got all the maps. I think I did that right. I think it goes like this. I'm sorry about that, guys. I think you go like this. Yeah. Okay. Just making sure I did it correctly. I'm sorry about that. At the midpoint of the 20th century, nuclear energy was widely promoted as a clearly preferable alternative to fossil fuels. It was seen by many as the answer to the expanding energy needs of core countries, especially as the supply of uranium worldwide was thought to be more than adequate for centuries of use. Nuclear energy was also regarded as cleaner and more efficient than fossil fuels. Although nuclear war was a pervasive threat, and there were certainly critics of nuclear energy, even in the early years of its development, the civilian atomic age was widely seen as a triumphant technological solution to the energy needs of an expanding economic system. It is when serious accidents at nuclear power plants began to occur, such as those at Windscale in Britain and 3 Mile Island in the United States, Chernobyl in Russia, and now Fukushima in Japan, that the voices of concerned scientists and citizens were raised in opposition. Incontestable evidence points to the need to address the problems associated with nuclear energy production, such as how to ensure nuclear reactor safety and how to safely disperse dispose of nuclear waste, which remains radioactive for tens of thousands of years. After the devastating accidents and meltdowns, many countries decided to go nuclear free, such as Sweden, Denmark, Finland, and New Zealand. In light of the recent meltdown at the Fukushima plant in Japan, the safety of nuclear energy is again being publicly debated. France, for example, which derives 75% of its electricity from nuclear energy power, saw protest against its continued use emerge in the spring of 2011. Other opposition to nuclear power occurred across Europe, in Germany, Bulgaria, Italy, and the United Kingdom, as well as in the United States, Asia, and Latin America. And yet, while some core countries have moved away from nuclear energy because of the possibility of environmental disaster in the absence of fail-safe reactors, many more, and especially populous developing countries, are moving in the opposite directions. Even in the wake of the Fukushima disaster, given the world energy consumption is predicted to increase by 57% between now and 2030, it is not surprising that rapidly developing countries like India, South Korea, and China have growing nuclear energy programs. And developing Eastern European countries like Czechia and Romania, as well as Russia and Belarus, are continuing to invest in nuclear power. Biomass and hydropower. While nuclear power problems are still largely confined to the core, the periphery is not without energy-related environmental problems. Because a large proportion of populations in the periphery rely on biomass for their energy needs, as the populations have grown, so has the demand for fuel wood. One of the most immediate environmental impacts of wood burning is air pollution, but the most alarming environmental problem is the rapid depletion of forest resources, with other conventional sources of energy, coal, oil, and gas, being too costly, or unavailable to most peripheral households. Wood or other forms of biomass, any form of material that can be used as fuel, such as animal waste, livestock operation, residues, and aquatic plants, is the only alternative. The demand for fuel wood has been so great in many peripheral regions that forest reserves are being rapidly used up. Fuel wood depletion is extreme in the highland areas of Nepal, as well as the Bolivian and Peruvian Andes Mountains. The clearing of forests for fuel wood in these regions has led to serious steep slope soil erosion. In sub-Saharan Africa, where 90% of the region's energy needs are supplied by wood, overcutting of the forest has resulted in denuded areas, especially around rapidly growing cities. And although wood gathering is usually associated with rural life, it is not uncommon for city dwellers as well to use wood and other forms of biomass to satisfy their household energy needs. In Niamey, the capital of Niger, the zone of overcutting is expanding as the city itself expands. It is estimated that city dwellers in Niamey travel from 50 to 100 kilometers, 31 to 62 miles, to gather wood. The same goes for inhabitants of the Ogadua in Burkina Faso, where the average haul for wood is also over 50 kilometers. And fuel wood use in Asian and South American highland regions, as well as in sub-Saharan Africa, is expected to continue to increase substantially, 34% by some estimates, over the next decade at least. Hydropower. Hydroelectric power, also known as hydropower, was once seen as a preferred alternative to the more obviously environmentally polluting and non-renewable fossil fuel sources. The wave of dam building that occurred throughout the world over the course of the 20th century improved the overall availability, quality, cost, and dependability of energy, as well as harnessed water resources for food production, generation, flood control, and domestic use. Unfortunately, however, dams built to provide hydroelectric power as well as water for irrigation, navigation, and drinking for the burgeoning cities of the core and to encourage economic development in the periphery and semi periphery have also profound negative environmental impacts. Among the most significant of these impacts are changes in downstream flow, evaporation, sediment transport and deposition, mineral quality and soil moisture, channeling and bank scouring, and aquatic biota and flora, as well as the development of conditions threatening to human health. Furthermore, the construction of dams dramatically alters terrain, often with serious consequences. For example, clearance of forest for dam construction often leads to large-scale flooding. Felled trees are usually left to decay in the impounded waters, which become increasingly acidic. The impounded waters can also incubate mosquitoes, which carry diseases such as malaria. The effects on human population are also significant as dam projects often require relocation of long settled populations. These populations are often indigenous and their displacement disrupts social networks, generations long connections to the land, as well as established livelihoods. Despite these problems and in response to the rising cost of fossil fuels, the use of hydroelectricity is expected to continue to expand over the next 2 decades by 1.9% per year, particularly where its use is supported by government policies and incentives, such as in Asia and South America. The construction of Three Gorges Dam, as well as several other large-scale hydroelectric projects in China, illustrates this trend. In contrast, most of the increase in energy production in core countries is expected to be renewable resources, as shown in box 4.3, visualizing geography renewable energy resources. I think I put that thing on that. Energy-related pollutants. One reason hydroelectric power continues to be appealing in the periphery is that it produces fewer atmospheric pollutants than fossil fuels. Indeed, coal and gas power stations, as well as factories, automobiles, and other forms of transportation, are largely responsible for the increasing acidic quality of the Earth's atmosphere. Although it is true that people, as well as other organisms, naturally produce many gases, including oxygen and carbon dioxide, increasing levels of industrialization and motor vehicle use have contributed to the destabilization of long-term balance of such gases, leading to a serious atmospheric pollution, sulfur dioxide, nitrogen oxide, and hydrocarbons, among other gases, which are released into the atmosphere from motor vehicle exhaust, industrial processes, and power generation based on fossil fuels are increasing the level of acids in the atmosphere. If these gases reach sufficient concentrations and are not effectively dispersed in the atmosphere, acid rain can result. Acid rain or acid deposition, as it is known scientifically, is the wet deposition of acids upon Earth through the natural cleansing properties of the atmosphere. The term acid rain also includes acid mists, acid fogs, and smog. Acid rain occurs as the water droplets in the clouds absorb certain gases that later fall back to the earth as acid precipitation. Illustrates the widespread nature of acid emissions. The problem first emerged as a health problem in the industrial countries of the Northern Hemisphere, especially in the United Kingdom, Scandinavia, the United States, and Canada. In the 1950s, and eventually came to be seen as the environmental concern as well, acid deposition poisons soils and water bodies that become too acidic to support life. In urban areas, acid rain corrodes marble and limestone structures, affecting important buildings such as the Parthenon in Athens and St. Paul's Cathedral in London, as well as others in Europe. By the late 1990s, however, acid deposition became far less of a problem in Europe and North America, as decades of environmental regulations and cooperative agreements diminished the release of chlorofluorocarbons, CFCs, into the atmosphere. The problem has not gone away entirely, however, and is emerging with great negative effect in Asia, especially China, where few governmental limits on industrial pollution are in place. In fact, because of rapid industrial growth, China has some of the world's most polluted cities and rivers. The steady emissions of sulfur dioxide from unregulated factories and vehicles has resulted in 1/3 of China's territory being affected by acid rain, posing a major threat to soil, water, and food safety. Here is the map. There are a lot of maps in this, so I'll try and get them all, guys. I'm so sorry about that. And then here's figure 4.2. And here's 4.25. Sorry, I'll go backwards on that so you can get the actual key to know what you're looking at. And this one's 4.2. Land use and environmental impacts. In addition to industrial pollution and steadily increasing demands for energy, the environment is also being dramatically affected by land use. The clearing of land for fuel, farming, grazing, resource extraction, highway building, energy generation, and war all have significant impacts. Geographers classify land into 5 categories: forest, cultivated land, grassland, wetland, and areas of settlement. Geographers also speak of land use change as occurring in either 2 ways: conversion or modification. Conversion is the wholesale transformation of land from one use to another. Example, the conversion of forest to settlement. Modification is an alteration of existing land use. Example, a grassland overlaid with railroad line or a forest thinned and not clear cut. One of the most dramatic impacts is loss or alteration of forest cover, which humans have cleared for millennia to make way for cultivation and settlement. Forests are cleared not only to obtain land to accommodate population increases, but also to extract the vast timber resources they contain. The forested area of the world has been reduced by about 8 million square kilometers, about 3 million square miles. Since pre-agricultural times, rapid clearance of the world's forests have occurred through logging, settlement, and agricultural clearing, or through fuel wood cutting around urban areas, shows the global extent of deforestation in recent years. Forests, the permanently clearing and destruction of forest deforestation is currently occurring most alarmingly in the world's rainforest. The UN Food and Agricultural Organization has estimated that we are destroying rainforests globally at the rate of 0.4 hectare, 1 acre per second. Today, rainforests cover less than 7% of the land surface, half of what they covered only a few thousand years ago. Destruction of the rainforest, however, is not just about the loss of trees, a renewable resource that is being eliminated more quickly than it can be regenerated. It is also about the loss of biologist diversity of an ecosystem. This also translates into the potential loss of biological compounds that may have great medical value. In addition to the destruction of rainforests, can lead to the destabilization of the oxygen and carbon dioxide cycles of the forest, which may have long-term effects on global climate. Much of the destruction of the South American rainforests is the result of peripheral countries' attempts at economic development. In the Bolivian Amazon rainforest, the introduction of cocoa production has become an important source of revenue for farmers in the region and has led to the removal of small tracts of forest. The pressure of economic development persists in the region such the net rainforest and forest land more generally are continuing to decline in Central and South America at a faster rate than in the 1990s. Great geographical variability exists with respect to human impacts on the world's forests. For most of the core regions, the forests that were once cleared that have been replaced by regeneration. For most of the periphery, in contrast, clearance has accelerated to such an extent that one estimate shows a 50% reduction in the amount of forest cover since the early 1900s. Cultivated lands. Cultivation is another important component of global land use, which we deal with extensively in Chapter 9. In this section, we briefly cover 1 or 2 points about the environmental impacts of cultivation that are particularly pertinent to our current discussion. During the past 300 years, the land devoted to cultivation has expanded globally by 450%. In 1700, the global stock of land in cultivation took up an area about the size of Argentina. Today, it occupies an area roughly the size of the entire continent of South America. While the most rapid expansion of cropland since the mid-20th century has occurred in the peripheral regions, the amount of cropland has either held steady or been reduced in core regions. The expansion of cropland in peripheral regions is partly a response to growing population and rising levels of consumption worldwide. It is also due to the globalization of agriculture. See Chapter 9. With some core region production having been moved to peripheral regions, the phenomena of corporations and rich governments investing in the agricultural land of the peripheral countries is often called a land grab. In the popular press, while it is impossible to know exactly how much peripheral land is being sold to investors, because land deals are often secret, there are reliable estimates. The Land Coalition, a non-governmental organization, estimates that by 2011, almost 80 million hectares had been subject to some sort of negotiation with a foreign investor, more than half in Africa. To appreciate just how much land this is, 80 million hectares is more than all the farmland of the United Kingdom, France, Germany, and Italy combined. Big investors are countries with concerns about feeding their own people that purchase farmland abroad. I'll come back to this. As a guarantee for future food supplies, China is the largest of these investors, buying or leasing twice as much land as anyone else, usually in Africa. The most worrying aspect of these land grabs is the high levels of corruption among the buyers and low levels of benefit for the sellers. Grasslands. Distinct from agricultural land, grasslands are also used productivity the world over, either as rangeland or pasture for livestock grazing. Most grasslands are found in arid and semi-arid regions that are unsuitable for farming due to the lack of water or poor soils. Some grasslands, however, occur in more rainy regions where tropical rainforests have been removed. Other Others are at the mid-latitudes, such as the tall and short grass prairies of central United States and Canada. Approximately 68 million square kilometers, 26 million square miles of global land surface is currently taken up by grasslands. Human impacts on grasslands are largely of two sorts. The first is the clearing of grasslands for other uses, most frequently settlement. As the global demands for beef production have increased, the use of the world's grasslands has intensified. Widespread overgrazing of grasslands has led to acute degradation in its most severe form. Overgrazing has led to desertification. Desertification. Sorry. Desertification is the spread of desert conditions resulting from deforestation, overgrazing, or poor agricultural practices, as well as reduced rainfall associated with climatic change. Until recently, one of the most severe examples of desertification had been occurring in the Sahel region of Africa. The degradation of the grasslands bordering the Sahara Desert has not been a simple case of careless overgrazing by thoughtless herders. However, severe drought, recurrent famine, and the breakdown of traditional systems for coping with disasters have all combined to create increased pressure on fragile resources, resulting in a loss of grass cover and extreme soil degradation since the 1970s. However, increasing evidence is suggested that between 1982 and 2000, the desertification in this region has been declining. Scientists believe they are seeing signals that the Sahara Desert and surrounding regions are actually greening, adding biomass, including grasses as well as trees. Due to increased rainfall, the increased rainfall may be the result of global climate change, which is leading to warmer temperatures. Hotter air can hold more moisture, which in turn creates more rain. Aerial photographs as well as ground studies have confirmed the greening phenomena. The most optimistic projection of the various climate models that attempt to better understand the impacts of greening is that the rains could continue to revitalize drought-ravaged regions, providing new grazing lands for farming communities. Wetlands. I'll go ahead and get this map. I don't know if I did or not, just in case. And then this page, I was going to come back. This is visualizing geography. This is the 4.3. Let me go ahead and try and do it like this. I'm so sorry. I'm going to get as close as I can on this one. And then here is this. Sorry about that. I meant to go back after that last one. So, okay. Wetlands. The wetlands categories cover swamps, marshes, bogs, peatlands, and the shore areas of lakes, rivers, oceans, and other water bodies. Wetlands can be associated either with saltwater or freshwater. Most of the Earth's wetlands are associated with the latter. The human impacts on wetland environments are numerous. The most widespread has been the draining or filling of wetlands and their conversion to other land uses such as settlement or cultivation. One reliable estimate places the total area of the world's wetlands at about 8.5 million square kilometers, 3.3 million square miles, with about 1.5 million square kilometers, 0.6 million square miles, lost to drainage or filling. For example, Australia has lost all of its original 20,000 square kilometers, 7,740 square miles of wetlands to conversion. For the last 400 years or so, people have regarded wetlands as nuisances and as sources of disease in core countries. Technological innovation made modification to conversion of wetlands possible and profitable. In San Francisco, California, the conversion of wetlands in the mid 19th century allowed speculators and real estate developers to extend significantly the central downtown area into once marshy edges of San Francisco Bay. The gold rush in the Sierra Nevada sent millions of tons of sediment down the rivers into the bay, filling in its marshland and reducing its near shore depth. It is estimated that in 1850, the San Francisco Bay System, which included San Pablo Bay as well as Susani Bay, covered approximately 315 square kilometers, about 120 square miles. 100 years later, only about 125 square kilometers, about 50 square miles, remained. By the 1960s, the conversion and the modification of the wetlands, as well as the effects of the pollution pouring directly into the bay, has so dramatically transformed the water quality and the habitats of fish, fowl, and marine life that the viability of the ecosystem was seriously threatened. Since then, restoration activities have been undertaken, and parts of the bay have returned to something approximating their former state, but large parts are heavily urbanized and cannot be restored. Water use and access. One of the most crucial elements in the relationship between people and their environment is water. We can't live without it, and all of our economic practices depend on it. For instance, it takes 150 gallons of water to produce one newspaper, 1,000 gallons for 1 quart of orange juice, 2,500 gallons for 1 pound of beef, and 40,000 gallons of water for 1 new car. The water embedded in the production of the food and other things we consume is referred to as virtual water. Without abundant water, people in the core could not live at the high quality lives they currently enjoy. Without clean water, those in the periphery die. It's therefore important to question what our lives would be like if the price of water was as volatile as, for example, oil. The price of oil has risen and fallen repeatedly due to civil unrest in the Middle East, most recently, but also to the power of 12 countries, known as the Organization of Petroleum Exporting Countries, the OPEC, to set oil production schedules and prices. Privatized water could be subject to similar conditions and price effects when private companies set the price for water and not governments. Water rates in most municipalities around the world are subsidized since water is absolutely essential to life, and the real cost of water acquisition, treatment, delivery, waste management can be prohibitive. Moreover, subsidies exist not just for the households but also for the agricultural industries. And yet, while people in the core enjoy artificially low water costs because the government subsidizes the price of water in the periphery, populations have been feeling the effects of escalating water prices for nearly a decade, and in some places, far longer. The 2013 UN Human Development Report states that 1.1 million people in the peripheral countries do not have adequate access to water, with 2.6 billion lacking basic sanitation. Almost two-thirds of the people lacking access to clean water survive on less than $2 a day. Access to piped household water is unequal, with 85% of the wealthiest 20% of the population having adequate access, compared to a meager 20% of the poorest 20% of the population. Perhaps the most disturbing is the statistic that 1.4 million children will die each year from lack of access to safe drinking water and sanitation. Experts around the world have begun to talk about a global water crisis, which is occurring not because there is a shortage, but because water as a public good is rapidly turning into a privatized commodity. That is, the privatization of water rather than the provision of water through publicly owned utilities. Touted as a way of bringing equitable access and efficiency to all water users has instead led to increased prices and accessibility problems for poor and marginalized people, not only in the global periphery, but in peripheral areas, many core countries as well. Nearly 2 decades ago, many governments, national as well as local, looked to the privatization of water as a way of unburdening themselves of a relatively expensive service in response to the public's demand for smaller government corporations, mostly multinational ones, began buying up municipal water providers and offering water provisions based on profit and loss considerations. Here is how much water did your textbook cost? Virtual water. Okay. International water companies such as Paris-based Suez, the largest water company, Veolia, formerly Vivendi, also French, and the world's second largest water giant, and RWE, a German utility conglomerate, are competing for water supplies across the world. Since 2002, Lexington, Kentucky, for instance, has been fighting to regain control of its local water utility from RWE. The water privatization in New Orleans was predicted to be the largest private water contract in the nation when it proposed in 2000 Vivendi, as it was then known, and Suez vied to profit from control of Crescent City's California water supply. The deal was predicted to be worth more than $1.5 billion over the next 20 years. Ultimately, the city was able to defeat the takeover. Reports abound across the United States and the globe of private purchase of local water supplies and resulting rate hikes, negative economic impacts, inadequate customer service, and harm to natural resources. The bottom line is the water, clean, drinkable water, like lots of other natural resources, is becoming increasingly scarce and an attractive investment opportunity. One of the most significant challenges of the 21st century will be how to ensure the wide accessibility of adequate supplies of quality drinking water for the world's people. In response to the global water privatization movement, individuals as well as governments and non-governmental organizations are increasingly arguing that access to safe and adequate supplies of water should be seen as a human right, and large corporations are not capable of guaranteeing that right. It is important to be aware that the conflict over who should provide safe water is occurring in cities and towns throughout the core as well as the periphery. Besides issues of access to and public safety, Many of those I'm so sorry. Many of those opposing water privatization argue that conflicts over water are really about fundamental questions of democracy, and particularly if water is no longer a public good, who will make the decisions that affect our future access to it and who will be denied access? This question is an especially significant one as climate change is expected to have dramatic impacts on water quality and quantity throughout the world. The environment of global environment. The combustion of fossil fuels, the destruction of forest resources, the damming of watercourses, and the massive change in land use patterns brought about by the pressures of globalization, industrialization being the most extreme phase, contribute to environmental problems of enormous proportions. It is now customary to speak of the accumulation of environmental problems we as a human race experience as global in dimension. Very little, if anything, has escaped the embrace of globalization, least of all the environment. In fact, no other period in human history has transformed the environment as profoundly as the Anthropocene. While we reap the benefits of a modern day way of life, it is important to reorganize that these benefits have not been without cost. Fortunately, the costs have not been accepted uncritically over the last 2 or 3 decades. Responses to global environmental problems have been on the increase as local groups have mobilized internationally. Global environmental governance. The increasing importance of flows and connections, economic, political, social, and cultural, means that contemporary globalization has resulted in an increasing shrinking world, in addition to allowing people and goods to travel farther, faster, and to receive and send information more quickly. A smaller world means that political action has also become connected across the globe. It can now move beyond the confines of the state into the global political arena where rapid communications enable complex supporting networks to be developed and deployed, facilitating interaction and decision making. Good examples can be seen in the protests that occurred at the World Trade Center, the WTO, meeting in Seattle, Washington. In 1999, at the Group of Eight G8 summit in Genoa, Italy. In 2001, at the Asian Pacific Economic Corporation Summit meeting in Bangkok in 2003 around the UN Climate Negotiations Conference in Copenhagen, Denmark in 2009, and again during the UN Climate Change Conference in Cancun, Mexico in 2010, telecommunication, as well as Facebook, Twitter, and other social media sites enable protest leaders to organize and deploy demonstrators from interested groups all over the world, such as political protests, reflect attempts to match the political reach of the institutions like the WTO, the International Monetary Fund, the IMF, the World Bank, and the United Nations. One indication of the expanding influence of and geographical extent of popular political groups is the growth of environmental organizations whose purview and memberships are global. These organizations have emerged in response to the global impact of such contemporary environmental problems as fisheries, depletion, global warming, genetically modified seeds, and the decline in global biodiversity. Since the 1990s, those groups ranging from the lobbying organizations and non-governmental organizations, the NGOs, to direct action organizations and political parties like the Green Party in Europe, and drawing on the distinctive traditions and varying It's getting late for me. Varying levels of resources have become an important international force. Increasingly, agreements and conventions protecting biodiversity are being created, and not a moment too soon. The decline in the diversity of simple foodstuffs like lettuce, potatoes, tomatoes, and squash occurred most dramatically over the course of the 20th century. For instance, in 1903, there were 13 known varieties of asparagus. By 1983, was just one, a decline of 97.8%. There were 287 known varieties of carrots in 1903. This number today is just 21, a fall of 92.7%. A decline in the diversity of foodstuffs means that different resistance to pests inherent in these different varieties have also declined, as have their differential nutritional values and tastes. It should be pointed out, however, that a growing local food movement in the core countries is working hard to recover some of these lost varieties. Moreover, new sources of medicine may be lost not only because of the deforestation in tropical rainforests, but also because of the decline of indigenous languages, cultures, and traditions. Recognizing that many indigenous peoples have extensive knowledge of local plants and animals and their medicinal uses, the Convention on Biological Diversity that emerged from the Rio Summit in 1992 is attempting to protect global biodiversity by preserving and protecting these cultures and traditions. Traditional knowledge and practices are being lost as globalization homogenizes languages and draws more and more people into the capitalist market. The UN Environment Program devotes a great deal of its energies to biological and cultural diversity. Even the WTO has begun to recognize the value of indigenous knowledge and the promise of biodiversity through its advocacy of intellectual properties rights of both corporation and indigenous peoples. For the latter, this means protection against bioprospecting, the scientific or commercial practice of searching for a useful application, process, or product in nature, often in extreme environments such as deserts and rainforests, and cold places like Arctic and Antarctic. Seed savers exchanges saves heirloom seeds. This is the ozone hole. Here's 4.4 window of the world. Oh, sorry about that. And then here's the map. This is the growth of the shark ecotourism. I hope you can read that. Okay, sorry about that. Clearly, global environmental awareness is on the rise from both ends of the political spectrum, including the conservatives such as the WTO and the progressives such as the programs devoted to preserving genetic diversity in seed strains. This increasing awareness is directly responsible for the staging of global environmental conferences like Rio in 1992, Kyoto in 1997, and the signing of the Montreal Protocol in 1987, a treaty meant to halt the growing hole in the ozone layer. Antarctica, over 25 years, scientists say, and policymakers unveiled what the United Nations called the most successful treaty in UN history. Nearly 200 nations signed the Montreal Protocol on substances that deplete the ozone layer, and thereby agreed to ban the use of chlorine and bromine based chemicals, particularly chlorofluorocarbons or CFCs that destroy the atmospheric ozone. It is widely accepted that this international agreement likely saved the world from an environmental crisis while setting an example for how to develop and implement policy. Sometimes I just have to stretch. Okay, so sorry about that. Environmental sustainability, the interdependence of economic, environmental, and social problems, often located within widely different political contexts, means that some parts of the world are ecological bombs, time bombs. Most environmental threats are greatest in the world's periphery, where daily environmental pollution and degradation amount to a catastrophe that will continue to unfold in slow motion in the coming years. One approach to this problem that has emanated from core countries is ecotourism, also known as sustainable tourism. We examine this well established but still growing form of alternative tourism. Box 4.4, Window on the World of Ecotourism. In the peripheral regions, there is simply less money to cope with environmental threats. The poverty endemic to peripheral regions also adds to environmental stress in order to survive. The rural poor are constantly impelled to degrade and destroy their immediate environment, cutting down forests for fuel wood and exhausting soils with the overuse in order to meet their debt repayments. Governments generate and export earnings by encouraging the harvesting of natural resources in the cities of the periphery. Poverty encompasses so many people in such concentrations as to generate its own vicious cycles of pollution, environmental degradation, and disease. Even climate change, an inherently global problem, seems to pose its greatest threats to poor peripheral regions. A more benign relationship between nature and society has been proposed under the principle of sustainable development, a term that incorporates the ethic and intergenerational equity with its obligation to preserve resources and landscapes for future generations. Sustainable development involves employing ecological, economic, and social measures to prevent environmental degradation. While promoting economic growth and social equality, sustainable development insists that economic growth and change should occur only when the impacts on the environment are benign or manageable, and the impacts, both costs and benefits, on society are fully distributed across classes and regions. This means finding less polluting technologies that use resources more efficiently and managing renewable resources, those that replenish themselves, such as water, fish, and forests, to ensure replacement and continued yield in practice. Sustainable development's policies of major international institutions such as the World Bank have promoted reforestation, energy efficiency, and conservation, and birth control and poverty eradication programs to reduce the environmental impact of rural populations. But cities and towns throughout the world have also launched policies and practices meant to foster sustainability at the local level. These include reorganized municipal waste programs where cities collect organic waste in turn and turn it into rich and usable soil, or remove some of the most problematic elements of it to keep it from entering the landfills, or even converting organic waste into energy. The recycling networks are not only local but can span the globe, so that material deemed as waste and in an affluent country can be exported to a less affluent one where it takes on new value in a different context. Indeed, the global transfer of obsolete goods is big business. In so that in 2008, the transfer of the scrap and other waste material exceeded the value of all semiconductors and electronic goods exported by the United States to China. Excuse me. There is also an emerging movement known as the transition towns. The practices undertaken in this movement are based on a group of active citizens who wish to improve the resilience of their communities in the face of threats like climate change and even economic uncertainty. These citizens work collaboratively to find local solutions. As their websites transition towns succeed in by regeneratively using their local assets in innovating, networking, collaborating, replicating proven strategies, and respecting the deep patterns of nature and diverse cultures in their place. Transition initiatives work with the deliberation of good cheer to create a fulfilling and inspiring local way of life that can withstand the shocks of rapidly shifting global systems. Future geographies. The continued expansion of the global economy and the globalization of industry will undoubtedly boost the overall demand for raw materials and energy and continue to shape the relationship between people and nature. While the extraction of raw materials will be important in the future, the issue of most concern by far will be energy resources. World energy consumption has been increasingly steady as the periphery is industrialized and its population increases further. The demand for energy will expand even more rapidly. Basic industrial development tends to be highly energy intensive. The International Energy Agency, assuming fairly optimistically that energy in peripheral countries will be generated in the future as efficiently as it is in developed ones now, estimates that developing country energy consumption will more than double by 2025, lifting total world energy demand by almost 50%. Unless peripheral countries are able to limit degradation associated with energy use, the globe will continue to feel the negative public health and environmental effects of air, water, and terrestrial pollution. Despite the threat of people and the environment, industrialization, geared to meeting the growing worldwide market for consumer goods such as automobiles, air conditioners, refrigerators, televisions, and household appliances, will continue without higher rates of investment in exploration and extraction than at present. Production will be slow to meet the escalating demand. The past 25 years have seen a growing public awareness of how continued globalization will affect the world. Increasingly, citizens, non-governmental organizations, and environmental policymakers are expressing concern over the negative outcomes of rapid and enduring global economic growth. However, because of growth is so critically tied to improving the lives of poor people around the world, governments are reluctant to limit it. The response from the global community, hammered out during international meetings through academic publications and in response to social protest, is to link globalization to governmental cooperation across the states with the assumption that global challenges will require international political and economic cooperation. In conclusion, let me see if there's any graphs or charts. No, it is just a picture. But this one is the Karangi. The other one is a ship. I'm hoping I can get close enough so you can read that. This is the ship. Waste containers. Conclusion. The relationship between people and nature is to a great extent mediated by institution and practices, from technology to religious beliefs. In this chapter, we have seen how the nature society relationship has changed over time and how the globalization of the capitalist world economy has had a more widespread impact on attitudes and practices than any cultural or economic system that preceded it. The expansion of European trade, followed by colonization and eventually industrialization, broadcast worldwide. The belief that humans should take their place at the apex of the natural world. The Western attitude toward nature, as manifested by the capitalist economic system, is the most pervasive shaper of nature society interactions today. In addition to exploring the history of ideas about nature and contemporary environmental philosophies and organizations in the United States, this chapter has shown that people and nature are interdependent and that events in one part of the global environmental system affect conditions in the system elsewhere. Finally, we have shown that events in the past have shaped the contemporary state of society and nature. In short, as economies have globalized, so has the environment. We can now speak of global environment in which not only the people, but also the physical environments where they live and work are linked in complex and essential ways. Along with the recognition of a globalized environment have come new ways of thinking about global economic development. Sustainable development, one of these new ways of thinking, has come to dominate the agenda of international institutions as well as environmental organizations as the new century unfolds. Here is the learning outcomes revisited. Should you wish to read this? Try not to make it so that... Sorry guys, I've had to do a couple of midterms today. Here's the key terms. Don't worry, I will go through and do the review discussion. I just want to make sure you can get all of these terms. Review and discussion. And then unplugged. Here's the data analysis. And then here is the, if it'll focus, hopefully it'll focus. Lovely. There you go. Now it focuses. And this is the end of chapter 4. Thank you.